Just an example, I'm going to design a circuit that will behave like this. If I am at this stage, I'll have 4 stages: A, B, C, and D. I'll put them like this. If I'm at stage A and my input is 0, I go to stage B. But if it's 1, I'm going to go stage D. If I am at B and my input is 0, I go back to A. But if it's 1, I'm going to go to C. If I am at C, my input is 0, I'm going to go back to A. And if it's 1, I'm going to go back to B. And if I'm at D and I get a 0, I'm going to go to C. And if my input is 1, I want to stay at D. I want to build a circuit that will behave like this. So when you look at this, there's only one input. That's this input, X. So where you're going to be next, it depends on where you are on this map plus what X is. If I'm right here and X is 0, I go right there. If I'm right here and X is 1, I go to this one. So it depends where you are, the current state, and whatever your input is. You can see I have how many states here? 4 states. That's my state diagram. I have 4 states. So maybe what I'm going to do, create a code that state A will be represented with 0, 0. State B is going to be what? 0, 1. State C is going to be 1, 0. And state D is going to be 1, 1. I had to use 2 digits. Why? Because 2 to the power of the number here, n. You want that number to be greater than or equal to the number of states. Since I have 4 states, I have to use 2 flip-flops. So I'm going to design that. Now I'm going to decide what kind of flip-flop I'm going to use. So let's say I decided to use JK flip-flop. No reason why I picked JK. So I want to go to the lab and build that circuit using JK flip-flop. I'm going to need 2 flip-flops. So 2 JK flip-flops. Okay, let's look at my state table now, that state diagram. Let's look at the state table. Come on. Just rip this piece out. There we go. Here's my state table. I have I'm going to jump ahead a little bit. When I'm building this is what I'm going to use 2 flip-flops. So this is 1 flip-flop right there. This is 1 flip-flop, and there's the other flip-flop. And what are you going to attach to them? What are we going to attach to these flip-flop to make sure they work? So if I call this number 1, flip-flop number 1, and this is flip-flop number 2. So this is my J1, this is my K1. It has 2 outputs, Q1, Q1 not. and has a clock on the bottom. We'll put the clock. This is my second flip-flop. That's J2, K2. This is Q2, Q2 not. And again, usually these are running off a clock there because you don't want them off sync. So this is the clock. As the clock goes to 0, 1, they all flicker at the same time. That's my clock. And what do we attach to each one to get actually the flip-flop to go from 0, like follow the state diagram, where I am based on X, where to go. So that's where I'm going with this. To get to it, I need to do something else before this. So that page is going to come back later, so let me just rip that page, put it aside for now. And let's look right here. So I have, you want it back there? One right here. All set? Yep. Okay. So now I'm going to make the state table for that. I'm going to look at the current state. I also have X for an input. These are my inputs. And I'm going to look at my output, which is, I don't have really physical output. It's not going to give me a candy or anything. But we're the next state. So the current state is where we are, right here. So we said this is state 0, 0. This is 0, 1. Remember, this is 1, 0. We label them, and this is 1, 1. So my current state is Q. I'm using my picture. I'm using Q1 on the left. You see that? Q2 on the right? I'm going to stick with that notation. That's the flip-flop on the left. That's the flip-flop on the right. So here's my Q1, Q2, that's the current state, and this is X, my external input. This is the next state, Q1 asterisk, the next state, where should it go, and Q2 next. And now let's look at it and see. This is 0, 0. When X is 0, if your state 0, 0 and X is 0, where do you go? Can you see the state diagram? You go to 0, 1. The next state is 0, 1. If you're at 0, 0 and X is 1, you go to where? State D, which is 1, 1. If you are state 0, 1, that's this one, and X is 0, where do you go? To state A, which is 0, 0. If you're at 0, 1 and X is 1, 0, 1, and X is 1, you go to C, which is 1, 0. Now let's continue. If I'm a state 1, 0 and X is 0, and 1, 0 and X is 1. Here's the 1, 0. When X is 0, where do you go? 0, 0. But if you're 1, 0 and X is 1, where do you go? 0, 1. See it? Back there to 0, 1. And finally, if you're state 1, 1, X is 0, 1, 1, X is 1. 1, 1, you're right here. If X is 0, you go to C, which is 1, 0. And if you're at 1, 1, and your input is 1, you stay there at 1, 1. And that's my state table. I got that from this picture. Now, we know what Q1, Q2, X, Q2 next, Q2. Okay, that sounds wonderful. So how do we figure what that is? So I'm done with this one. I can put it aside for now. This one I'm holding it because I'm not done with it. But let me look at Q1. If I'm using JK, flip-flop, this is the current state, that's the next state. What is JK should be? J1, let's put it here. What's J1 should be, and what's K1 should be? Well, to answer that question, we need to go back and revisit what a JK flip-flop looks like. You remember what the JK flip-flop, the truth table for it? Where's the JK flip-flop? That's a D flip-flop. Still D, SR, JK. Here we go. Can you see it? When J is 0 and K is 0, the next state is the same as the previous state. So let me write that down. This is the JK. This is the Q next. When it's 0, 0, Q next is the same as Q previous, stays the same. When it's 0, 1, that's a 0. When it's 1, 0, that's a 1. When it's 1 to 1, that's what? Q1 or Q complement. You complement the previous state. That doesn't help me because I got to think backward now. What do I mean by thinking backward? How about if I tell you what the current state is? The current, C for current, and this is the next state. Can you tell me what J and K should be? I want you to think backward. If your current state is 0 and you want to stay 0, or 0 to 1, or 1 to 0, or 1 to 1, these are the four options. From 0 to 0, that means what? You staying the same. It seems like J is 0, K is 0, but it's not it. Why? That's one way to do it. What's the other way? How do you make the next state 0? 0, 1. So you could do either 0, 0 or 0, 1. That means as long as J is 0, who cares what K is? That's 0 and don't care. You can get to it either way, with 0, 0 or 0, 1. Everyone see that? From 0 to 1, I'm complementing. That looks like 1, 1 down here. Can you see it? When it's 1, 1, you complement the previous state. It was 0, became 1. That's one way. The other way, if it's what? 1, 0. It will make the next state to be 1. So as long as J is 1, don't care about K. Now the next one. 1 to 0. That looks like a complement. Or, which one? 0, 1. If it's 0, 1, you're going to force that state to be 0. Can you see that? As long as don't care, then 1. The last one, you can keep it the same, Q previous, because it didn't change. That's 0, 0. Or what? or 1, 0. If you do 1, 0, it's going to force the next state to be what? 1. So as long as what? Don't care and 0. That's your excitation table. This is the one I'm going to use up there. I'm going to look at Q1 previous or current state. That's the next state. I'm going from 0 to 0. 0 to 0. I need J to be what? 0. K, don't care.
So Q1, Q2?
Yep. 0 to 0. I might as well do them while I'm at it. Any more 0 to 0? That's it. 0 to 1. The next one. 0 to 1, 1 and don't care. One to 0, don't care, and 1. 1 to 0, don't care, 1. 1 to 0, don't care, 1. 1 to 1, don't care, and 0. Now let's look at the second flip-flop. That is, where'd you go? That's this one. And this way you want it to be. So I'll put it here. And here. I like to use the color this way. I know what I'm looking at. So that's J2 and K2. J2 and K2. Notice 0 to 1. Where is 0 to 1? 1 and don't care. 0 to 1. 1 and don't care. 1 to 0. Don't care and 1. 1 to 0. Don't care and 1. So keep my eyes on fixed. 0 to 0. 0 and don't care. 0 to 1. What's 0 to 1? 1 and don't care. 1 to 0. Don't care and 1. And 1 to 1. Don't care and 0. That is my state table now. Since I want to design the smallest circuit possible, I need to do a K-map for this, K-map for this, K-map for this, K-map for that. Everyone see that? A K-map for each one of them. That's part of the course, I think. It's the fun stuff. Love this stuff. You really have to be neat with this, you know. That's where these boxes come in handy. As much as people complain about the grid paper, it makes it easy on the eyes. I'd like to use the code so when people look this and this to get that one, this and this to get that. I'm using this table actually to get these numbers. I got this from this one, working it backward. So I need a K-map for J1, K1. Notice there's 8 inputs. 8 possibilities. I have 3 inputs. What are the inputs? Q1, Q2, and X. Your output depends on the current state and whatever X is. Did we do horizontal or vertical? I can't remember. Horizontal? Okay. So I'm going to make four K-maps here. Try to be neat a little bit. And let me put a line through it. That's the top and bottom half. I need another one now. That's J1 and K1. And I'll do one for J2 and K2. Engineers, we're supposed to be really neat.
Can we be like doctors?
Well, you could be, but nobody will be able to read your design. Doctor just can't
Better
write.
question is, why can't doctors be neat?
This way when you sue them, they don't know. I didn't say that. I didn't write that. Okay, perfect. So one for J1, one for K1, one for J2, and one for K2. Notice I have three inputs, Q1, Q2, and X. So this is Q1, Q2, I'll put X on the bottom. 0, 0, 0, 1, 1, 1, 1, 0. Q1, Q2, X. Q1, Q2, X. Q1, Q2, X. And now let's look at J1. Here we go. 0, 1. 0, 1. Don't care, don't care, don't care, don't care. K1. Don't care, don't care. Don't care, don't care. 1, 1, 0, 0. J2. 1, 1. Don't care, don't care. 0, 1. Don't care, don't care. K2. Don't care, don't care. 1, 1. Don't care, don't care. 1, 0. Now if I read each one, I'm done. Well, the bottom one, I can group it by what? Remember, the don't care, we only use them if they help us. That would say what? Should be X attached to that. K1, notice, there's two ones. I can take the two ones here with this. That means I don't need actually X. X is gone, it's changing. Q1 is changing, Q2 not. J2. Well, I can take these four ones. X is gone. Q1 is 0. How about Q1 not? Or I can take this, which is what? X. Or I could group the 0, actually, it would be the same thing. K2 here.
X bar plus Q1 bar.
Yep. This will be X bar. This one, which is what? Q1 bar. So all we're going to do now, attach these pieces to it, and I'm done. There's only one input, one external input. If you look at the circuit, going back to it, there's only one input, and that's this input. So now I'm going to build that one. Where's my flip-flop that's waiting for me? I made it a few minutes ago. Still waiting. Right here. J1. What are you going to attach to J1? X. So you have a switch. That's your X. That toggle. You attach it here. K1. What's attached to it?
Q2.
Q2 bar. So I'm going to take the output from this, loop it around, attach it right here. Can you see it? In the lab, that would be just a wire. Doesn't have to be that nice, neat, and folded this perfect way. But that's what we tell them. You need to take this wire and attach it to K1. What's J2? It's an OR gate. Come on. It's an OR gate. And what's going to it? Q1 naught and X. Q1 naught, that comes from here. I'm going to need it later for that one. So that's Q1 naught. And what else attached to it? X. And what's K2 is going to be? Another OR gate. And attached to that is Q1 bar, which is, that's why I extended this one a little bit longer. And what else? X bar, not X. And if we build this circuit and we reset everything to 0, 0 on both these guys, the lights are off, and we start playing with X, you will see it actually move in the sequence we're supposed to be. There's only one input, and that's X. So notice my output, which is in this case what the next state, that's what my output is. Again, if I put an LED here, light, to see if the light's going to be on and off. Initially, if I'm at 0, 0, if I preset these, make them go to 0, the lights are off. And I go, okay, let's make X be 0. Well, if I'm at 0 and I make X 0, what should happen here? Based on this one, it should go 0, 1, right? So the light should stay off, but this will go to 1. Then you go, okay, let me move X back up to 1. If you move X back to 1, guess what happens? It goes to 1, 0. This light will be on, that will be off. I'm here now, and if I make X 0, it goes back right there. If I take X and move it to 0, it should, both of these lights off, but if I make X stay at 1, I'll go back to this one. There's only one actually input, outside input, and that's your X. And based on that, where you are and what X is, that will tell us the direction we're going to be traveling in. Where we're going to be next. And again, this is the first time that actually we're looking at flip-flops, where an output is depending on the current state and whatever the input is. I'll stop this video here. We'll do more of these next time.